Thank you very much. My name is Gewecke. I'm really excited to be here in Brussels today. And I'm thrilled to share what we're working on here at Niantic Spatial. What we're doing is really cool, and it's fundamentally new. We're using the power of AI to build a smart, living model of the real world. Our model will tell you exactly where you are in 3D space. It will let you build a precise digital twin of your surroundings. It will give you a human-like understanding of everything that's around you. It's designed to let AI interact with the physical world. Now, why do we need that? Let me talk a little bit about how I got here today. I just arrived in Brussels from London. I traveled from our offices right in the center of Covent Garden. I wanted to take an Uber to the Eurostar, but my colleagues in my London office said I was crazy. It would take me an hour in London traffic. So I made my way through the crowded streets to the tube station. I eventually got to King's Cross. I tried to find my platform. Got a little distracted. There's this place called Hogwarts. Finally, I got to the right place. I was soon on a train to Brussels. Now, I'm not here today to give you travel advice, obviously. But this short trip is a great example of how the real world is full of amazing places and landmarks and neighborhoods, people. At the same time, moving through the real world is messy, it's complicated, it's unpredictable, it's physical. At Niantic Spatial, we are building a new product that connects AI to the problem of human physical reality. It's designed to give machines spatial intelligence about the world. To put this in context, let me just draw a contrast with other kinds of AI model that we're all familiar with. But all of us here today probably use LLMs every day. It's actually hard to believe that ChatGPT launched 3 years ago. LLMs are trained on the world's text. They're amazing tools and engines. They're sort of the ultimate in book smarts. But they're not really very good at helping you understand the physical world around you. And this year we've begun to hear a lot more about a new kind of model, world models. World models are trained on video and on sensor data. They're models that are designed to build synthetic, simulated, imaginary worlds. They're an amazing new tool for video game levels or for creating special effects in movies and TV shows. As someone who spent nearly 2 decades in the entertainment business, this is an incredibly cool innovation. And these models have many interesting uses. For example, they can really help a lot with robotics training. You can imagine letting a robot learn what rooms are like by having it train in a synthetic, imaginary, virtual room. But we humans don't live in a synthetic world. When I raced down the steps to the tube in London, I wasn't running for an imaginary train. When hundreds of millions of people play Pokemon Go, they're outdoors in real life. They're walking in parks, they're exploring their cities. We live in the real world. And AI needs a model that deeply understands the real world, and that's what we're building. A smart, living model of the real world that people and machines can talk to. It's the foundation for a new kind of AI, one that understands space the way that humans do, one that's constantly updated because the world is constantly changing. You might almost call it a shared spatial memory of the real world. Now, in some ways, this is a brand new thing. Our company was launched 6 months ago. But in fact, in many ways, what we're building today is the culmination of 25 years of thinking about geospatial technology. Our founding team is the same team that started Keyhole 25 years ago. That's the company that went on to become Google Earth. And that same team then went on to build the mapping business at Google, and 10 years later, they invented the entire genre of walk-around-the-world mobile games and really changed the world again with the global phenomenon of Pokemon Go and many other experiences. Now, to make those games work, we had to build an amazing new technology, a spatial computing stack that could fundamentally visualize the world around you and let you place objects within it. And then a few months ago, we spun that technology off into our new company, Niantic Spatial. So we're building on all of that history to bring this extraordinary new vision to life. A smart living model of the world that truly connects atoms to bits. It's designed to turn physical space into what you might call a programmable surface. Something that, in effect, in the world of robots and AI glasses, essentially creates an entirely new medium from the fabric of the real world. And let me show you just a little bit more about this in this video.
Niantic Spatial connects AI with the real world, bringing intelligence to the places we live, work, and explore. We do this by building a large geospatial model that people and machines can talk to. It starts with a traditional digital map with tens of millions of landmarks and local businesses. A 3D base map adds dimension, enhanced with high-resolution scans of the real world, from aerial platforms like drones to ground-level sensors like phones, robots, and AI glasses. Those fragments are processed, aligned, and georeferenced, then used to train a series of powerful models. In a sense, this is a map built for computers, not for humans, to help machines understand and interact with the physical world. Once complete, these models provide three key services. Reconstruction transforms raw scans into detailed 3D visualizations, powering inspection, simulation, and collaboration. Localization enables precise navigation, contextual insights about the world, and AR experiences. And with semantic understanding at every 3D point, our map can answer open-ended questions about the world, giving people and machines the context they need to navigate, interpret, and understand large spaces. Together, these services bring intelligence to the real world, powering AI, wearables, and robotics, and helping machines truly understand the world around them.
So we have this large geospatial model, our living model. It's a powerful system that drives three main services. We have localization, our visual positioning system, we call it VPS, tells me exactly where I am in the world. We have reconstruction, which allows us to create accurate georeferenced digital twins in 3D. And we have understanding, which is our service that tells us what is happening in the world through advanced semantics at every 3D point. And so going a little deeper into localization, you can think of localization, really, it's like our model is like having a friend with a photographic memory of the whole world. You look around, we figure out where you are in the world. We can even do that without GPS. We figure out exactly how you're positioned and oriented in 3D space. We build an invisible point cloud around you, and then we can anchor any content, any telemetry, any intelligence to that point cloud. We're fusing digital intelligence to physical space. And that can help you navigate and wayfind through the world or enhance your experience of the world and so much more. As one example, our partnership with Meow Wolf is designed to test the limits of what's possible when you can think of the real world as a canvas or a surface. Meow Wolf, if you haven't been there, it's a fundamentally new kind of location-based entertainment experience. It's an incredible immersive art adventure that you can visit in Santa Fe, in Denver, in Houston, Las Vegas, Dallas, and soon in New York and LA. And with Meow Wolf, we're using VPS in beautiful and clever and unexpected and subtle ways to help bring the magic of the Meow Wolf experience out into the real world, and then to help visitors start their experience before they even arrive. And you can see in these videos and these images how having a super precise model of the real world helps to deliver this blending of the real and the imagined, and in the process can create a truly one-of-a-kind immersive experience. And just today, just this morning, we announced that our VPS will be powering a landmark XR experience from Ubisoft and Sugar Creative. This city-scale experience brings the Assassin's Creed universe into the real world, allowing visitors to relive the founding of the US. It'll launch next year. It takes place in the streets of New York and Boston. And our VPS will anchor digital content to physical landmarks. You can walk by a location and experience historical moments exactly where they took place centuries ago. And as Daniel mentioned earlier in his amazing presentation, earlier this year we announced a major partnership with Snap to bring our localization capabilities into the Snap ecosystem. And AR developers will be able to use our VPS to place AR content at millions of real-world locations with centimeter-level accuracy. And this includes integrating VPS into spectacles, enabling a wide variety of place-anchored AR interactions. We're really excited about the possibilities here. And you can actually try this yourself. We have the Peridot demo with Snap Spectacles that Daniel showed at the end of his presentation. I'll show a little bit here again as well. We're showing it here at United XR over in the expo hall. Come over and check it out, and our team will take you on a tour, or check out the QR card at the end of this presentation to sign up for it.
Hey Dot, take me to the main stage.
All right, let's go. Right this way. The main stage is straight ahead. What sounds interesting to you here? What's next on our adventure? Let's go.
You can never have too much Peridot. So you can think of our VPS service as sort of an invisible scaffolding that connects AI to the real world. But we can also create this highly visible, high-quality digital twin of that same space around you. These are extraordinary, high-resolution, immersive visualizations of the real world. They're high-density Gaussian splats, which we can combine together to create incredible large experiences. And we can do this from data gathered from drones, from handheld cameras of any kind, from robots, from AI glasses, from mobile phones. We can do this processing on device, where it's very fast, it's private and mobile. We can do it in the cloud, especially for large-scale mapping, multi-user projects. And these visualizations can be indoors, delivering this beautiful, effortless journey through any space, as in this example of this home. We could do it at an industrial site, a power plant, an oil refinery or construction site. We can do it outdoors. This is an incredible splat that we took recently of the neighborhood around our London office. It's generated using consumer-grade 360 cameras. And you can see the scale and the distance and the size of the area that we're capturing here. And then we have the ability to bring this all together, many different capture modes, sort of sensor fusion, all in place. This capture of Pier 39 in San Francisco, it meshes imagery from drones, from handheld cameras, and from mobile phones all together into a single integrated rendering that you can experience through any camera path. And so these technologies allow us to scan everything from a very small 10 by 10 point of interest all the way up to much larger areas. Parks, city squares, entire city blocks, entire neighborhoods, and ultimately cities and even larger spaces. A truly immersive visualization of the world. There are endless applications for these powerful visualizations. Just to give one example, we're partnering with Echelon, which is one of the world's leading providers of advanced flight simulation environments. And we're testing this capability with the United States Coast Guard at their National Aviation Training Center. We're starting with reconstructions that focus on critical areas like helicopter landing zones to help make training environments more realistic. But much more is possible. I mentioned our technology allows you to take a mobile phone and create a super high-quality Gaussian splat visualization of a space in under a minute. And so you can imagine a scenario where you have the search and rescue team in the helicopter going to a new location. They're going to a landing zone that perhaps they haven't been to before, or whose topology has changed because of a flood or a hurricane. You have first responders on the ground with their phones, and they're scanning in the landing zone. They're sending the detailed 3D visualization to the helicopter while it's in transit. The pilots are able to visualize the landing in their minds, prepare for it, have better situational awareness. That is something that is very possible, and it's exactly the kind of thing they're working on and looking at first responder opportunities in a variety of scenarios. And there are many, many more applications like that. So let me pause for a moment and sort of think about what can happen if you bring all this together. What's our sort of vision for the combination of these sort of capabilities in the future? If you have incredibly realistic visualization and you have the ability to fuse content seamlessly onto the atoms of the physical world. Earlier this year, we were thrilled to announce a partnership with Kojima Productions, the visionary studio behind the incredibly popular game Death Stranding. We're working together on a future project that will use our geospatial AI to power an immersive experience that brings the world of Kojima Productions to life and tries in a very deliberate way to weave narrative into the fabric of the real world. Let me show you in this video a vision of what the future could look like when you bring these technologies together.
Reach to the stars. Dream with your heart. Fading away will break you apart. Stand up, stand tall as you are. Don't be afraid. The light will guide your way. It's a big world after all. It's a big world after all. It's a big, big world. Dive deep in the dark. Look, you've come so far. Don't walk away before you can start. Stand up, stand proud as you are. Don't be afraid. The light will guide your way. It's a big world after all. It's a big, big world.
I can't wait to live in that world. So, with localization, we can anchor intelligence to the real world, and we can provide next-generation wayfinding and all sorts of other experiences. With reconstruction, we can create detailed, immersive 3D visualizations. And the final service we provide is that we can build a layer of semantic understanding at every 3D point. That lets us answer open-ended questions about the world, giving people and machines the context they need to navigate and interpret and understand large spaces. So if you think about it, any human being, without any training at all, can stand anywhere in the world today and instantly apprehend and understand tens of thousands of pieces of information about what's around them. And they sort of perceive the significance and the meaning of everything in the space that surrounds them. It's just built into how we perceive the world as human beings. But a computer or a robot or even an LLM today simply does not have that innate spatial context or understanding. Our model understands the physical world in a nuanced and layered and human-like way, and enables that kind of interpretation and querying and action. So this capability is powered by our semantic services. These are built on open set semantics, which means we don't just detect shapes, we encode meaning at every 3D point. There are no fixed categories or vocabularies, so new objects can be identified without needing to retrain the system. In effect, we can turn the physical world into a database. We can turn any space into a smart, three-dimensional, queryable space. And that allows AI systems and robots to stop just navigating obstacles and start reasoning about the environment. This video gives a glimpse of some of the applications. This is drone footage that's been splatted and segmented. The data is geo-aligned, so we can query public databases and we can retrieve relevant information. We understand physical space in our model, so we can answer questions about what you're seeing. And then we can combine our knowledge with other AI knowledge to answer deeper questions. And here's another example where we're allowing the user to interactively ask any question they want about a large immersive space. And this is an example of sort of a a home tour, but you can imagine this in almost any other space, indoors or outdoors. Just open-ended questions about what you might be able to see. So that's a lightning tour about what we're building. We're building a new way to truly understand and interpret the real world. Now, we're building for a future world of AI glasses and wearables and robots, a platform for building real-time, semantically enriched digital twins. We're fusing input from humans and robots and sensors in real time and over time, building, in effect, 4D twins, what you might call a shared spatial memory of the real world. And that's how we get to a living model of the world that people and machines can talk to. For us, this is a new invention that will transform how we interact with the world. It lets us touch the real world with the power of geospatial AI, but it also keeps humans at the center of the story. It's a new map for a brand new world. Thank you.